So I made a game. Oh, let me change something. Yeah, I made a game with SDL2 with C. The GitHub is in the description. You can compile it yourself. Anyways, yeah, it was pretty much. Oh yeah, I want to thank tsoding or tsoding, or I don't know how to pronounce his name. He made it weird, probably on purpose. Anyways, he made a video where he made tic-tac-toe in C with SDL2. So his project, his code, and his video, they were really helpful. They made this a lot faster. It allowed me to do it a lot faster. I basically copied the code structure and just how to get SDL working. Okay, with that said, I'm just gonna get into it. So I'm gonna start by showing you what the game is, how it works, and then I'll go over the code and how it achieves what I need it to. So I'll start with the game. Yeah. Basically 3 years ago in 8th grade, there was nothing to do and we couldn't use our phones or anything, so we had to play tic-tac-toe, and I got sick of it and I wanted to make some sort of game to replace it. So and I really like it. It's played on a 4x4 grid, and you have 2 players. The goal of the game is to get as much as your piece, more of your piece than your opponent's piece on the board. I don't know if I explained myself well, but let's say you have 3 X's by the end and the other player only has 2, the X wins. So the strategic part is that you can only place your next piece adjacent to the one you previously played. So let's say X goes here, and let's do O goes here. So X, it now can only place right here, and O, now that it's X's turn, X thinks it's going to be clever, and it's going to use the neutral piece. Neutral piece is the strategic piece that both players can control, and when they put it down, when they use it, they lose their turn. So now O, let's say O wants to use the piece to put it over here. X goes down here, O goes here, X goes here. O pretty much is stuck and decides to put a square right here. X realizes what O is trying to do and puts the square back here. So this is the path of the square. Okay, O goes here, X goes up here, O goes here. O no longer has any moves to make, so it's always X's turn until the end. So that's the path X took, that's the path O took. X is clearly the winner. So now let's go to how I did it in my game. Let me set this back up, run it. Oh my god, I kept the weird thing. I kept the weird resolution. Let me change it back here. Oh yeah, it's just a matter of recompiling it. Okay, so instead of X, I made it red, and instead of O, it's blue, and the neutral piece is gray. So blue will go over here, then red will block it here, blue will go over here, red will go here, O, and O, O here, and red wins. When a player wins, it turns into the color. The whole screen turns into the color of that player. If O wins, if blue wins, it turns blue, and if it's a tie, it's gray. Okay. So now let's go over the code. One interesting thing: if anyone watching is really smart, please try to solve the game, or come up with some sort of algorithm to best play it. I guess that's solving. anyways, let's go to the code. First, let's go to main.c, and I'm going to explain everything here. So basically, the code structure. Yeah, let's go to the code structure first. Main.c, that initializes SDL and handles user input. Then it sends that user input to logic.c, which alters the state of, which is game.h. Game.h contains the game state. Logic.c alters it, and rendering reads the game state and renders the screen based on what the game state is. Pretty simple. The way I probably would have done it would be have just one massive C file. So props to tsoding, because I didn't exactly know how to use header files and stuff like that before. So yeah, another thing that I learned. Okay, let's head back here. So again, main.c initializes SDL and handles user input. So let's go over what that looks like. First, you do SDL init. That's what you will always have to do every time you start an SDL project. You want to initialize SDL, and you want to have this. If it does not return 0, because when a program returns 0, it means it's successful. So if it doesn't, it means there's some sort of error. So you print out error and exit failure. Then we initialize the window. This creates a window. We call it blockade. This is where we put it, the position. We center it. We put it out. We center it here. And here, I'm gonna add some tabs. Okay. Okay. So it's named blockade. Again, this is its X position at SDL win pause center. That's just the center of the screen. It's the same for the Y. Then the screen width and screen height, they are defined in game.h. And I think this makes sure the window is shown. I'm not too sure what this means. Okay. Then this again returns an error if it cannot create the window. Okay, next it creates renderer. Renderer is like this. It's this weird sort of object. It's this abstraction, which is basically what is being drawn on the screen. So let's look at this at its flags. It's gonna be drawn to window -1. It specifies that it just says use the GPU drivers somewhere in this screen automatically. Don't mess with this if you are not if you don't know what you're doing. Basically, again, black magic. This, I don't know what render or accelerated means exactly, but I know this just activates vsync. If there is an error and renderer does not work, destroy the window. Return SD, return a failure. Okay, let's continue. This declares the game state at the beginning. We'll go over that later. Now, this while loop is the important part of this. These first parts, they're just setup. So we get SDL event E. And E is a variable where we're storing the game events. What buttons we click, what things are we doing. So next we go to a while loop, which when game.state does not equal quit state, it's just like if you haven't quit the window, then continue to the rest. So this quit state is defining game.h. Anyways, so if you do not quit, it sends mouse button down to. If it's mouse button down, it does this function, which is a function in logic, and it sends it the game state, the Y position divided by cell height, the X position divided by cell width, and the type of button you send. So whether it's like right click, left click, or like the scroll click. Okay, this sets the background to black. It clears for double buffering. I sort of forgot. This runs the render, the rendering.c. It runs that, sends it the render object and the game state. Should take it as a it takes it as a constant, and then I think this just presents it to the screen. I'm gonna go get some water to drink. My mouth is getting dry. Okay. Again. So let's go to game state now. I think I said, yeah, background is black, makes rendering visible and double buffering. This sends the game state and the object render to rendering.c, and then presents rendering to the screen. Not entirely sure about that last part. I'm just basing it on the name. Okay, so let's get a game state. What we're gonna need for the game. These macros are just stuff. If n for, so n, that's the number of rows and how high it is and stuff. So right now we're just declaring it as 4. We can change it to 5. And we compile it, and the game still works. Again, like I made it so that the gray limit is the same as the number of rows. So now this time it's 5. As you can see, we can't enter anything here. So blue wins. Okay, works as normal. This is the screen resolution, screen width, screen height. So we can make it something wonky, like 600 by 800, like I did before. No, wrong thing. Compile, run. Now it's all wonky. Okay. So I think it works best on a 4x4 grid. 3 is too simple. 5 makes it too long. 4 is perfect, especially when you're doing this on pen and paper, which I recommend is better. This was just a see if I can use SDL. Okay, so cell width, that's just the screen width divided by the number of rows and stuff. Same goes for height. If we're empty, okay, now these set of macros, this is what is going to be inside of the board. The board is a two-dimensional array made of n with the size of n on each side. So this is what's going to be inside of the board. These two also define the player turn. So empty is empty, red is red, blue is blue, gray is gray. That's what's going to be inside the board. This is the gray limit, the amount of grays that you can put. Again, gray is neutral piece. I don't know if yeah, I did clarify that, sorry. This is the game state. Whether it's running, whether red wins, whether blue wins, whether it's a tie, or whether you have quit. And quit is not used in rendering, it's just used in the main to like if you quit the game or not. Okay, so now this is the game structure, which is what's actually going to be affected by logic, by the logic .c. So again, our board is a two-dimensional array. Our player, well, that's basically the turn we're in. So yeah, it's either gonna be red or it's gonna be blue, one or two. Our previously played. This is gonna be used for the adjacency things. So it's a integer array of size 2. The first one, it's going to be its x-axis, so index 0 is its x-axis, index 1, its y-axis. Same goes for blue and gray. The red counter, you have how many reds you have placed. The blue counter, how many blues you have placed, and the same for gray. Okay. Red moves, the amount of red moves you have. Blue moves, the amount of blue moves you have. Gray moves, the amount of gray. I think gray might be redundant, but I don't feel like refactoring it just to fix that small thing, which is not really an issue. And the game state, that is, going to be these 5. Let's go to rendering. Okay. This function up here, that's the one that's called by main. So first we initialize our game over screen, and if the state is running, then we do render running state. But if it's not, this is when we're gonna show our game over screen. If it's the case that red won, game over screen is red. If it's blue, game over screen is blue. If it's a tie, it's gray. Okay, now for the real part, the rendering running state. So we first declare the size of the player piece, then then this checks inside of the board. So it's gonna check the index of the array as a way to multiply as the position for where you're gonna put the rectangle or square. It's gonna decide the color based on what's inside of the board. So if inside the board is red, then the color is gonna be red. Blue, blue. Gray, gray. And if it's empty, it's gonna be black. It only needs this for restarting purposes. So yeah. Then it renders the grid on top of all of that. The grid is gonna be white, and it renders a line. This is the starting point. This is for the vertical, I think. Yeah, this is the vertical line. It starts from cell width for deciding the x and y. The x is, the cell width times the first part, it starts at I1, so then it's 0. Does the same here, but this time the screen width, so it goes across the whole screen, and this is for the horizontal, does the same. Okay, so pretty basic. This is a constant. It takes the game structure as a constant because this should not change anything. Okay, now for the real part, for the logic. I imported std_lib so I can get the absolute value function. Okay, now so this is the reset part. We go over the simple stuff first. If we are not in the running state, if it's blue, if it's a red, blue, or tie state, then it resets the board. If it's a quit state, it doesn't matter because the whole thing's going to be shut down anyways. So this right here sets everything inside of the board array to 0. This here resets the player turn to red. Set these 3, set the counters for all back to 0. Changes the moves back to 1. By the way, the moves are either going to be 0 or 1 or 2 sometimes, because we just need them to be more than 0 in order to make sure the turns continue. So yeah, and then it sets the game state back to running. For those who are not that familiar, this arrow thing is basically referencing the game structure. Okay, so if the game is running, then it does player turn. Again, this one, it sends the game state, the row, the column, and the button as parameters. So what it first does is it runs do when no moves. Do when no moves, it's this thing that gave me a lot of trouble, because you see this right here. This actually should be on top, but as you can see, I'm gonna put it on top. It was at the bottom for debugging purposes. It was a really stupid bug that took too many hours out of my life. This, instead of being blue, it was red, and it was messing everything up. Anyways, so it ran player turn. So what that does, first it checks where you're, it checks this, which will, automatically change your turn based on whether or not you have whether blue or red have moves. And it will, but first it will check, if anyone has one. Okay, so next it checks if the place you clicked is empty. So if it is not, returns, and you go back up here. Next, it checks what button you clicked. It checks if you right clicked. If you did right click, you do gray, and it checks if the place. It checks if available. It also checks if the gray counter is 0, if it is, or if it's not 0, if it's less than 0. Sorry. So if it's less than 0, you can continue, but it also checks around if it's available. This is a common function that you do for all of them. So yeah, let's go to check if available. What it does, if the counter is 0, which means you have nothing on the board, none of that piece is on the board, then you return true. And it returns if the column minus the previous place of that piece, which is the parameters, one of the parameters you're sending, if it's greater than or equal to 1, and the same for the row, if it's greater than or equal to 1. This is just if it's adjacent, it returns true. If not, if none of these are true, then it returns false, which will not allow you to continue. Okay. Next, it sets the previous. It puts gray in that column and row on the 2D array. Then it sets the previous played gray to the column, the previous played row to the row, and then it switches turns. Here it checks if it's not a right click, so let's say it's a left click or a mouse button or like a middle click, just so long if it's not a right click, then it will turn to it'll check around the previous played, which is, we give that as a parameter. Then again, it'll update the board, change the colors, change the column and row, add to the counter, and change the turn. Same goes for blue. And now let's go to the do when no moves function. So for anyone who saw, do when no moves first runs this check moves function. So check moves, that provides some little countermeasures for check around. So for this, it checks if the if the pieces you're checking are not 0. Just, if they are 0, it'll stay 1, because in the beginning it was 1. If it is not 0, then it checks around. For the gray piece, it checks if it is not the limit. If it is the limit, then it's 0. Like the counter, sorry. If the counter is the limit. Okay, next, a does check around. Check around function has this monstrous, huge if statement. I can't even do it the whole screen, but I can tell you what it does mean. This first section is checking if what you're doing is out of bounds. Well, let's go to... Okay, first let me describe what this does. So, let me turn this off and go here. So let's say you are here and you have previously placed X is right here. This, wait, no. For making it better, let's say it's right here. Okay. What the check moves does is that in the array, it will check around. So it'll go here, it'll check here, 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 and here. The first part of the function is making sure you're not checking out of bounds. So it first starts with a for loop. It goes to this position where it is here, and then it goes here. It goes here, here. It's a nested for loop, okay? And it checks if it's not out of bounds. Then what it does is it makes sure where you are checking it is empty. If it is empty and you're not checking out of bounds, then you return 1. If it is not empty, or if none of this is true and you never return 1, then it returns 0. Okay. Then once you're done with all of these, red moves becomes red moves plus gray moves. Same goes for blue moves. Then do when no moves. Again, checks the moves, the amount of red moves left and the amount of blue moves left, or checks if it's above 0. Based on that, it adds the two. It adds red moves and blue moves, and if it's equal to 0, then we know they have no moves left, and you continue. This automatically switches the turns as previously stated. So yeah, that's it. I want to end off with just some advice on how to learn programming, based on my experience on learning programming, because right now at best I consider myself an intermediate at C. So yeah, the best way to learn programming that I found is to do your own projects, to find a cool little thing to do and try to put the components together, because it also teaches you how to problem solve. So try to put the components together and figure out how, and learn as you go. Learn as you go to doing the concepts. I've learned the most about C with my Wordle project. I've learned a lot about reading files and arrays. I've learned from SDL, I've learned the most out of just analyzing tsoding's project, which is just basically like the most I've learned of SDL. Pretty basic stuff, right? Just just learning how to start and drawing squares and lines. He did more complicated shape drawing stuff, but it doesn't really matter what shape I drew. Anyways, yeah, so make your own projects. I will say another general C concept that I did learn with this project was two-dimensional arrays. I learned more about two-dimensional arrays and pointing to structs. I still don't know the accurate terms for referencing and dereferencing and what does what, but I do know how to use it and how it works. That's all. Hope you enjoyed, and most of all, I hope you learned something.